Okay, so let us solve the first problem on big M method. So maximize z equals to 3x minus y. The constraints are 2x plus y more than or equal to 2 and x plus 3y less than or equal to 3, y is less than or equal to 4 and x and y are non-negative using big M method. So here z equals to 3x minus y is the objective function and these are the constraints. The very first step is we have to balance these constraints. Okay, so we have more than or equal to, we have to make that as equal to. Okay, so look at the left hand side here. So the left hand side is larger than the right hand side, so we have to subtract some positive quantity, let it be s1, and here in the left hand side is smaller than the right hand side, so let us add some positive quantity s2 so that it will be equal to 3. And here the left hand side is smaller than the right hand side, let us add some positive quantity to the left hand side so that it will be equal to 4. Okay, fine. So here s1, s2, s3 are non-negative. Now let us equate x and y as 0, okay, in order to check the feasibility of this solution. Now so if I substitute x and y equal to 0 in this constraint, what happens? So minus s1 equal to 2, so that is nothing but what? S1 equals to minus 2, but s1 is non-negative here, so we have to introduce one artificial variable in this constraint. So we have minus s1, so let us instead introduce plus a1, and observe this constraint. If I substitute x and y equal to 0, s2 equal to 3, which is more than 0, and y, if I substitute y equal to 0, s3 equal to 4, which is more than 0. So in these two constraints, no need to introduce the artificial variable. So here we need to introduce the artificial variable, right? Fine. And from this constraint we can have the value of a1, so that is 2 minus 2x minus y plus a1. So now we have a objective function, new objective function. So we introduce the artificial variable, so the objective function becomes, yes, it is z, the maximize z equals to 3x minus y minus m times a1. If it is minimization, so we have to write plus m times a1. For the maximization problem, we need to write z equals to 3x minus y minus m times a1. So a1 is artificial variable. If you used two artificial variables, then you need to write minus m times a1 plus a2, right? Fine. Now let us substitute the value of a1 from this equation. So we have the value of a1 here. Let us substitute that, and on simplification we have this. So we have the maximization of z equals to 2m plus 3 into x plus m minus 1 into y minus 2m and minus m times s1. So subjected to this constraints, so we have to consider 2x plus y minus s1 plus a1 equal to 2 and x plus 3y plus s2 equal to 3 and y plus s3 equal to 4, where s1, s2, s3 and a1 are non-negative. Okay, so let us write the table now. So we have a initial simplex table, so let us write the non-zero variable x, y, and we have three constraints, so s1, s2, s3 and one artificial variable we use there. Let us mention that, and the right hand side is quantity. And for the first constraint, so we need to write we have the slack variable s1 as well as a1, so we need to write a1 here. And in the second constraint we have s2, and in the third constraint we have s3, and this is for the objective function delta. Okay, so let us write these coefficients. So look at the first constraint. So this is the first constraint, right? So 2x plus y minus s1 plus a1 equal to 2. So what is the coefficient of x? 2. Let us write that here. What is the coefficient of y? 1. What is the coefficient of s1? Minus 1. What is the coefficient of s2? 0. Coefficient of s3 0, and coefficient of a1 equal to 1, and the right hand side is 2, right? And look at the second constraint. So the coefficient of x is 1, the coefficient of y is 3, and the coefficient of s1 is 0, the coefficient of s2 is plus 1, the coefficient of s3 as well as a1 is 0, and the right hand side is 3. And look at the third constraint. The coefficient of x, the coefficient of s1, the coefficient of s2 are 0, right? And the coefficient of y is 1, and the coefficient of a1 is also 0, and the right hand side is 4. And to write this, you need to observe the objective function now. So look at the objective function. So this is the objective function, right? So look at the coefficient of x. So we need to write if the coefficient of x is a, we need to write minus a, right? So here the coefficient of x is 2m plus 3. Let us write it as minus times 2m plus 3. We have a coefficient of y as m minus 1. We need to write minus times m minus 1, that is 1 minus m. And the coefficient of s1 is minus m, let us write plus m. And the coefficient of s2 is 0. The coefficient of s3 and the coefficient of a1 is 0. But look at the quantity. To write the quantity, so look at the constant term here. So minus 2m is the constant term. Let us write that as it is. Don't change the sign. Let us write that as it is. Okay, fine. So this is what? This is your initial simplex table. So what we used to do earlier for in the simplex method, we will in the delta row we will identify the smallest negative number. What is the smallest negative number here? So minus times 2m plus 3 is the smallest negative number. So this is what? This is your pivotal column. And in the delta row we need to identify the smallest non-negative term. Okay, so sorry, we need to identify the smallest positive quantity. Okay, if you have 0, in that case also you have to consider that. Okay, so here let us calculate the quantity by the pivotal column elements. So 2 by 2, which is 1, and 3 by 1, which is 3, and 4 by 0, which is infinity. Among these three numbers we have to consider the smallest positive number. So here 1, 3, infinity is there. Among these two, the smallest one is 1. So let us consider this as your pivotal row. The intersection of pivotal row and pivotal column will be your pivotal element. So 2 is the pivotal element. So what is the next step? And look at the corresponding variable x has to replace with a1. And later we need to in the next table we need to make this 2 as 1 by suitable row operation. Okay, and we need to make this as 0, and it is already 0, and we need to make this term also 0. Okay, so in the pivotal column we have to make the pivotal element as 1 and the other elements as 0 by suitable row operations. So this is R1, R2, R3 and R4. Now tell me, how can you make this pivotal element 1? Let us divide the entire row by 2. So that 2 by 2 is 1, 1 by 2 is okay, minus 1 by 2, and 0 by 2 0, 0 by 2 0, and 1 by 2 is 1 by 2, and 2 by 2 which is 1. Okay, and later we have to make this element as 0. So look at this, let us call this as R1 dash, the new pivotal row. Okay, so here I remember one thing, while doing the other pivotal column 0, you have to do the row operation with either the old pivotal row or the new pivotal row only. Okay, fine. So now you have 1 here, and in the new pivotal row we have 1. Let us do the subtraction. So R2 changes to R2 dash is equal to what? R2 minus R1 dash. Okay, so 1 minus 1 0, 3 minus 1 by 2 5 by 2, 0 minus 1 by 2 plus 1 by 2. So 1 minus 0 1, 0 minus 0 0, 0 minus 1 by 2 minus 1 by 2, 3 minus 1 2. Right, and look at the third row, it is already 0. Let us write that row as it is. And we have minus 2m plus 3 here. I want to make this 0. So look at this row, this is your R4, right? I want to make this 0. How can you make this 0? So look at the new pivotal row, we have 1 here, and here we have minus 2m plus 3. So let us multiply 2m plus 3 to this row. Okay, so that 1 into 2m plus 3 is 2m plus 3, and here we have 2m plus 3. Let us add that with minus 2m plus 3 so that it will be 0. So the row operation will be what? R4 plus 2m plus 3 times R1 dash. This is your R1 dash, new pivotal row. So what happens? This is the thing we come across. Okay, so later again we have to identify the smallest negative number in the delta row. So minus 3 by 2 is the smallest negative number. So this is your pivotal column. So we have to calculate the pivotal row. How can you do that? So let us consider the ratio of quantity by pivotal column element, right? So here let us consider q by s1. So we are 1 by minus 1 by 2. If you have negative ratio, ignore that, because we are looking for a smallest non-negative quantity. Okay, fine. And 2 by 1 by 2, which is 4, and 4 by 0, which is infinity. So among these two numbers, the smallest non-negative quantity is 4. So this is your pivotal row, right? So the intersection of pivotal row and pivotal column, this will be the pivotal element. So in the next step, we have to make this 1. How can I make this 1? By multiplying throughout by 2, and we have to make the other three elements as zeros. It is already 0, don't bother about this. Okay, so let us write the pivotal row first. So we have 1 by 2. Let us multiply throughout by 2, so that it will be plus 1. So let us write r, let us multiply the second row by 2. So 2 times r2 dash, that is 2 into 0, 0, 2 into 5 by 2, 5, 2 into 1 by 2, 1, and 2 into 1, 2, and 2 into 0, 0, minus 1 by 2 into 2, minus 1, and 2 into 2 will be 4, right? Later I want to make the other three elements as zeros. Look at this, is already 0. Let us write this row as it is. Okay, and I want to make this row as 0. So this is your old pivotal row, and this is your new pivotal row. So in the old pivotal row we have 1 by 2. In the new old pivotal row we have 1 by 2, and in this row we have minus 1 by 2. Let us add them. Okay, so that it will be 1, so that it will be 0. Plus 1 by 2 minus 1 by 2 will be 0, right? So we have 0 plus 1, 1, 5 by 2 plus 1 by 2, this is 6 by 2, which is 3, and minus 1 by 2 plus 1 by 2, 0, 0 plus 1, 1, 0 plus 0, 0, and 1 by 2 minus 1 by 2, 0, 1 plus 2, 3. Later I want to make this as 0. How can here I have minus 3 by 2. In the new pivotal row we have plus 1. Let us multiply this row by 3 by 2, and here we have minus 3 by 2. Let us add them, so we will get this. Now look at the delta row. So all the entries of delta row are non-negative, so we arrived at optimum simplex table. So here we can say that x equal to 3, this is x equal to 3, and we don't have y here, so let us treat y as 0, and 9 is what? That is the maximum value of z.